Move y is equal to 3x squared in order to make it into y is equal to 3x squared plus 6x plus 8 graph. Trying to see how much we need to transform our y is equal to 3x squared graph in order to get our y is equal to 3x squared plus 6x plus 8 graph. But if you think about the transformation of graph, if there's one function and if there's another function, we count it as our vertex. So our vertex is location. And the vertex is the only way that we can see how it transformed on the coordinate plane. So if you find our y is equal to 3x squared graph, the y is equal to 3x squared plus 6x plus 8 graph's vertex difference, we're going to get our transformation. At first, let's think about what it is to be a vertex. So at first, for the vertex, it is a thing that is defined by the leading coefficient of the quadratic function, which we usually notate it as a. And when that value a is greater than 0, the graph of quadratic function will go upward. When the quadratic function's graph goes upward, for example, look like this. This quadratic function will only contain a minimum point, which we also call it as lowest point of the graph. And for the second case is a case where the a value is less than 0, which means when the a value is equal to negative, the quadratic function's graph will go downward. When the quadratic function's graph goes downward, for example, that is like something like this. It will only contains a maximum point, which we also call it as the highest point of the quadratic function. And for the kind of concept of the vertex is a thing that we add the two number possibilities of minimum point and the maximum point. This is what the vertex is. And it is basically going to be defined by the value of our leading coefficient sign. So at first, let's think about from the y is equal to 3x squared graph. From the y is equal to 3x squared graph, its minimum point will going to be 0, 0. The reason is because if there's any function that does not contain any constant, it will going to be 0, 0 can be either a maximum or a minimum point. But in this case, the a value, which will going to be 3 in this case, is always obviously greater than 0, which means 0, 0 will going to be the minimum point of our function. So this is our vertex of our function. And let's think about the second one where y is equal to 3x squared plus 6x plus 8 graph. So y is equal to 3x squared plus 6x plus 8. From here, in order to solve for the vertex, we need to convert this into a vertex form, which is specialized and optimized when it comes to solving for the vertex. When it comes to solving, we're converting into a vertex form. Only terms that we're caring about is our x term, which means we can put our parentheses 3x squared plus 6x, and then we have our plus 8 isolated in the outside. But before I do that, if the leading coefficient, which in this case will going to be 3, if it is not equal to 1, it's hard to solve for it. So all we have to do is we can take our 3 out from our parentheses, which will look something like this, x squared plus 2x. And for the unknown quantity that I'm pointing out right now that can be constant should be half over of the first degree term in the square, which will turn into plus 1. But we cannot just add plus 8. If you use the distribute property in order to cancel out this parenthesis, 3 times 1 will turn into 3. But then we need to try to get our plus 8, which means if we just add 5, we'll be able to get our function. So from here, we can simplify our x squared plus 2x plus 1 into a perfect square. So this will going to be 3 times x plus 1 squared plus 5. And this is our vertex form that we converted. And we can know one thing from here is that from this vertex form, our leading coefficient is equal to 3, which means it is obviously going to be the positive, and this vertex of our quadratic function will going to be the minimum point of our function. And if you find our vertex, it will going to be -1, 5, where the x value is equal to -1 and the y value is equal to +5. So if you see the difference between -1, 5 and then 0, 0, that will going to be our transformation. So let's write this. So for the transformation, for a transformation of two function, the first function's vertex was 0, 0, and the second one's vertex was -1, 5. And they'll probably moved it as x-axis and also toward our y-axis. If you see the difference between 0 and the -1, the only difference will going to be -1, but it is the x value, so we can see that they moved the original function toward the x-axis direction for -1 time. If you see the 0, for the 5, which will going to be y value, difference between two of those will going to be 5. So we can see that in order to get our 3x squared plus 6x plus 8 form, y is equal to 3x squared graph, is that when you move the 3x squared graph to the x-axis for -1 time and the y-axis to the 5 times. So our answer of this question will going to be toward x-axis direction for -1 time and toward the y-axis direction for 5 times. This will prove our two graphs to our quadratic function's coordinate plane. First, let's draw y is equal to 3x squared graph first. So for the y is equal to 3x squared graph first, 0, 0 will going to be vertex, and let's find some points to graph it. It is a quadratic function, which means we need at least 3 points to graph it. And if you input the value of 1, 1 squared will turn to 1 times 3 will turn into 3. If you input the value of -1, -1 squared will obviously going to be 1 times 3 will going to be 3. So we can actually plug these points. 0, 0, 1, 3, -1, 3. So the graph will look approximately like this. That passes through our 3 points and each required, and it satisfies our equation y is equal to 3x squared. Let's think about another function. Y is equal to 3x squared plus 6x plus 8. And we know that our vertex will going to be -1, 5. And let's plug in the value of 0. When the x value is 0, we're gonna get 8. When the x value is -1, for example, or let's say 1, 1 squared will turn to 1 times 3 will 3, And then 6 times 1 is 6, plus 3 is 9, plus 8, we're going to be 17. So if you actually plug these points, so I'll do in white color, -1, comma 5. So -1, comma 1, 2, 3, 4, 5. This will going to be its minimum point. And then 0, comma 8, 1, 2, 3, 4, 5, 6, 7, 8. And then if you input the value 1, you will go all the way up. But we need some points to graph, so let's plug in our negative values. If you input -2, it will turn into -2 squared. 4 times 3 is 12. Plus -2 times 6 is -12. And then plus 8. It will turn into positive 8. So when you input -2, it will turn into positive 8. Which will the graph look something like this. If you draw it again in a more approximate way, graph should look like this. But if you think about the transformation between two graphs, we obviously need to see the difference between two vertices. And the difference between two vertices was to the x-axis direction for -1 times, -1 times, and to the 5 times, 1, 2, 3, 4, 5. This was going to be the difference between two functions, which will end up being a transformation.